Hello everyone, thank you for being here, joining at this session. I don't know if you were at the previous session. Basically, Peter spoiled half of my talk. But if you went at his session, you are going to learn something new, because I'm going to talk more about how Testcontainers works with Spring Boot. So a little bit about me. I'm Iván. I am a JVM developer. I've been working for that for a long time. I'm a staff software engineer at VMware, although probably for no long, because Broadcom happened. So if you want to know more about, discuss about that, we can talk afterwards, offline. I'm the coordinator of the Madrid group, user group. I'm from Madrid, from Spain. I've been running the group for 12 years or so, and for the last couple of years, we've been doing joint talks with Madrid Java user group. So basically, I want to encourage you to join. If there is a Java user group in your city, go there, because you will meet people that will have the same interests. They will be interested in the JVM as you, so you will meet new people. And if there is no you in your city, you can create a new one. It's an amazing way to meet more people. And I've never been a developer advocate. I'm not a developer advocate, but I like to give talks, so I've been quite a few places. And basically, that's it about me. So how do we test? If you are kind of old enough or gray, if you have gray hair, you probably are familiar with this, right? This is when we started testing applications a long time ago. This is how we learn. We learn about this pyramid, and at the bottom of the pyramid, we have these unit tests, and the base is white because we have a lot of unit tests, right? So we should write unit tests. They are fast. And they are easy to write sometimes and to maintain, but we need to deal with mocks, so basically, sometimes they are not that easy, right? On top of that, we have integration tests, because in that kind of layer, we test our real integrations, right? So for example, the best example is our database, right? We want to make sure that when we write something to the database, it's already there, or it is saved. And these integration tests are more complicated to write. They are slow because you have some external dependency, right? And on top of that, we have our end-to-end or functional tests, or whatever you want to call them, which are, you have less of them, and because they are more complicated to maintain. So if you are, for example, testing a RESTful API, you will just, for example, send requests to the API to make sure it works as you expect. Or if you have an HTML UI, you can use Cypress or Selenium or JEP or any of those tools to kind of write those tests, right? To click here, click there, write some values, and check that everything works on the UI. This is how we learn, but what happens now is that we've been writing code in a different way in these days. I don't want to talk about microservices, right, because there was a hype, everyone wanted to write microservices, but we have something like this. It's not the same. We write different services, right? They talk to each other, so we need to focus more on the integration part. It's not like the pyramid when we write monoliths 10 years ago. It's more about the integration of different services. They can be bigger, smaller, whatever you want, right? So we need to approach this thing with this integration test to make sure that everything works. So how we can test that? What options do we have? So we can use shared instances. So you can have some server there with that dependency that you need, and you can use that, right, from your test. And they are shared because maybe you are saying, yeah, for this project, use this thing, this database, and this is the schema. And for this other project, this is the other database, this is the other schema. You can also install them locally. And locally, it doesn't even mean on your laptop. You can install them on your CI, right? If you are running, I don't know, some Jenkins, you can, I did that in the past, right? Install Postgres on my Jenkins server to have one Postgres available for my integration test. But then another team came and said, yeah, but I also want to install Postgres, but I need a different version. So you need to install a different version of Postgres. You need to change the port because by default it uses the same, and it's a mess. And another approach can be, for example, talking about databases, to use an in-memory implementations. You probably know H2, it's an in-memory database. The problem with these in-memory databases or with these in-memory dependencies is that they are not the same as a real one. I was working in a project a long time ago. It was a Grails application, and Grails by default uses H2 for integration tests. So we were using Postgres, and what happened was that we have a lot of integration tests for the database, and there was an error on production. And we were pretty sure that we had tests for that case. So we checked that, the tests were there, all the tests passed. But we were running the tests against H2. So we switched from H2 to Postgres on our local laptops just for running the test. And what happened was that more than 50 tests failed, right? Because it's not the same database, it's not the same transaction behavior, there are differences. So you need to make sure that you use the same dependencies on production or on your test that you are going to use on production. So how we can do that, right, with test containers. So test container is a library or a set of libraries that allows us to run some dependencies, external dependencies, on a Docker container. And the nice thing about nowadays, we live in 2024, is that we can run pretty much everything we need as a Docker container. So we don't need to find a way to put something in the container, because probably that exists. And if it doesn't exist, you can always grab inside that generic container, but it needs to be very specific, because there are a lot of things that you can run on test containers. So the first implementation that basically started the project was the Testcontainers Java. And to give you an idea of the timing, it was created almost or around 9 years ago, and Docker is around 11 years ago. So basically a year and a half, 2 years before Docker started, they started to create this first version of Testcontainers Java. So it was almost a decade ago. It started everything with the Java implementation, but nowadays there are implementations for pretty much every language, or the main ones. So if you are programming with Golang, .NET, Python, Node.js, whatever, you have a specific test containers implementation for your language. So you don't have any excuse to not use it. Test containers Java, and I think probably all implementation will behave the same, but I don't know the details. But the Java one uses the Docker API under the hood, meaning that it doesn't run the CLI, or it doesn't run commands like docker run, docker exec, docker whatever. It uses the low-level API, it talks directly to the Docker socket to do a lot of things better than with the CLI, but you don't need to worry about that. And it runs in any Docker-compatible environment. So if you don't have Docker, but you use, I don't know, Podman or any other thing like that, it will work. Maybe for not all the cases it works, because there are some differences, but probably for 95% of the use cases, it will work with another implementation. And of course, it has an amazing integration with frameworks and libraries that we use in the Java world. So for Spring, Micronaut, Quarkus, JUnit, Spock, you have amazing integration, and we are going to see how well it integrates with Spring Boot. So these are just a few modules, and having a module for test containers means that there is a specific integration for that. So if you are talking about, I don't know, a Postgres database, having the integration means that you can ask the module, the Postgres module saying, or the Postgres container say, give me the URL, the JDBC URL of the database, or give me the username, and give me the password, because that's what I need from my application. And if you are using RabbitMQ, you need the broker URL, right? So there are a lot of them, more than here in this slide. But the idea basically is that there are a lot of things already integrated with test containers, and you can, and if you are running something very specific and there is no integration, you can grab it in another generic container. We'll see an example of that. So this is kind of pretty my last slide. So what I have here is a demo. I'm going to basically show you an application, and we are going to see how we can test it. So it's a pretty simple application, but it has a few moving pieces. So here on the top, you can see we are going to send a send request, a post sign, to this message service. So basically, we are going to send plain text, and we want to calculate or generate a signature of that text. So what we're going to do is, when we receive that request, we are going to first save the text on the database, and we are going to send a message through Kafka saying, I want to sign that message, right? This is with the ID of the message and the plain text. And this other service is going to get that message, is going to sign the message, and then it's going to reply back on Kafka again with the signature of the message. And then the message service here is going to find the message that it previously stored on the database, and it's going to update the signature. Right? So this is the full picture. It's, as I said, it's pretty simple application, but it has a few moving pieces. So if we want to make sure that we test this properly, we need to deal with Postgres, we need to deal with Kafka, and we need to make sure that everything works properly. So let's switch to the IDE, and first let's basically run the application. Let me start this. I'm going to show you the code. But first, let's do a quick demo. So let's run the app. So I'm going to send a message, right, to the /messages, hello Fern, and then I have another get endpoint to get all the messages. So you can see it's already signed. Let's do it again. Send the same one, and you can see at the first the signature and this sign at are null, and after a few time or a few seconds, the message or the signature is there, and we can get it, right? So I have this endpoint, and I have another one to get a message basically by ID. So pretty simple application, as I said. So let's go to the code and let's see how this works. Let's stop this. I'm going to basically kill everything. Yeah, the application is complaining because I stopped Kafka. So we have. So don't worry about the code. I'm going to push the code and the slides afterwards, so you don't need to make notes. Just attend the talk, and then you can analyze the code and play with it at home. So pretty simple application. Latest Spring Boot version, Java 21, a few dependencies, web, JPA, Kafka, Flyway for running our migrations. We will see this later, and a bunch of dependencies on test implementation and test containers. So pretty simple. I have a Docker Compose that you saw there. So I have Postgres and I have Kafka. And what else do we have? So this is the entity we are persisting on the database. The UID is generated. This is the text that we sent. Created that, signature, and sign at. We are using JPA. So if you use JPA, you know that we cannot use records because we need this empty constructor, and we need the object to be not to be immutable. Spring Data JPA repository, nothing fancy here. What else? So we have here the controller. So this is the post. When I save the message, I will return the UID of that message, and then I will response accept it. So this is HTTP, I think 202. In the location header, I put the message, so basically the URL to get information about the message. This is that endpoint, messages/ID. Find on the repository, map it to OK if it's there, and return a 404 if it's not there. And then the other endpoint is the one that returns all the messages, right? So this one is to get only one message by ID, and this other one will return a list of all, or an array of all the messages, right? So what else? The service. So we have here, when we try to save the message, we save on the repository, and we log a message requesting to sign this message, and we send this message. So we are now here. We are saving it, and we are here sending this message through Kafka to ask the other service to sign or to calculate that signature. So we send to this topic this unsigned message, which is a record, basically the UID on the text. And this is here. And here what I'm doing when I receive this message is basically I put asleep. Don't do this in production, right? I need that asleep basically because it will run that fast without the sleep that we won't be able to see anything. So the code is going to sleep from 1.5 seconds up to 3 seconds. So we can see something going on and we can test in a different way. That's why before when I sent this first, it was null, right? Because it was sleeping there, just waiting to basically to this timeout. Then I calculate the signature. Another disclaimer, don't use this in production. MD5 has been broken, it has collision, is not the hashing algorithm used. But this is great for a demo because this dependency comes directly from the Spring framework. So I don't need to add an extra dependency for the demo, but for production use a proper algorithm. So yeah, I get the signature, I put another message sign, and then I sent a message back, this sign message here with the same ID, and now the signature, and this message, it's here, sorry, the other one. So as I said, now we are here, right? We find by ID and we update the signature. So we find the message, it should be there, but just in case, we update the signature, we update the sign at, and we update the database, right? So this is the whole application, and what we want to do is we want to test this application to make sure that it works properly with real integration tests. So before, what else I'm missing? Yeah, so I have a flyway migration to basically create the table, right? This will be run on, when we run our integration tests. And for my configuration, basically I have my local database running on the Docker Compose, and the same for Kafka. So before going into the details of how to test this application, let's kind of do a quick Testcontainers 101, right? In case you miss the previous session. So I have a test. I annotated with Testcontainers. This annotation is from Testcontainers with the JUnit integration. And what I'm going to do here, basically, I create a generic container. This generic container is what I mentioned before. If you don't have a specific integration for the thing you want to test, you can always grab whatever you want inside this generic container. I'm using this traffic whoami, which basically it's an echo service. You send a request and it will send you back the request and it will log some information. And I know this service is running on port 80. So that's it. And then what we are going to do, it's pretty simple. We are going to send a request to this localhost 80, and we expect that. So we send here the request and we log the body, and we expect that the status code is okay, right? So if we run this, what is going to happen, it's that it's going to fail. And if we see here why it fails, it says, it says here, connection refused localhost 80. And why this is happening? Because this is the port that the image exposes, but this port is not mapped to one of my free ports on the operating system, so we don't know which port it's bound, right? It's a random port, and you need to be random to basically avoid collisions of that. So how do we fix that? The right way to fix this is basically do not hardcode this, but as the container like this. Where is the host in which you are running? By default, it will be localhost, but in some setups, especially on CI, maybe it's not always localhost, right? So it's better to ask the container, give me the host and give me the first map port, because I only have one. If I have here defined multiple ports, I will ask for a specific one, right? The port that you map for the 80, and it will return it back. So it's the same test as before. I log the new URL. Let's run it. And now it should pass. It passed. And as you can see here, 32771, so one random port. We send the request to this host name. And this is kind of the echo of this traffic whoami, and the test pass. And you saw that it was pretty fast. And another thing that you need to take a look here, let me do this here. So it's running, it's connected to my local Docker daemon, and just take a look at this because it will be important at the end of the talk. This Docker is running on my laptop, Linux Mint 21.3, and well, this is my memory, 32 gigabytes. So remember this, because then we will see what happens when we switch to another test containers or another backend implementation. So this was basically this quick test containers 101, and now let's go to see what happens when or how we properly test this with our Spring integration. So the first thing, I have a test. I'm going to show you this in a couple of seconds. So this is going to be an integration test. So I'm going to auto-wire the application contents, and for my first test, what I want to make sure is that the application starts properly and both beams are created. So nothing really fancy here, just a quick test. And I'm running the test, and you can see it's a functional or integration test, but it's failing, and it says it's failing because it cannot connect to the database. So I have a database configured, and the database connection is eager, so when the application starts, it needs to go to the database, and the database needs to be there. So how do we fix this? Or how do we implement that? Let's take a look at the abstract class. As I mentioned, sorry, it's a Spring Boot test application. It starts on some random port. Here I'm injecting the port, and we will take a look at this afterwards. But the first thing you need to do, because what we need is a database, right? So there is here a property, and we can say Spring data source URL. If we go to their application, we need to basically provide this information. Where is my database? So we can say here, let me copy this. So we can put something like this, and if I had my database running, it will work. The problem is that here I'm not using test containers. So what we need to do to make this work is that we can put here as a special JDBC URL. If we write here TC, the Postgres the test containers Postgres driver or library will know how to interpret this URL. This is a special URL, and it will know that it needs to start a Postgres container for us. But we need to provide more information, or we need to define here. So, for example, the database. Do you know the database that the library is going to start? We don't, so we can delete it. Do we know the port? No, we don't. We don't know the local host. The only thing that we know is that we want to start, let me open Docker Compose. We want to start a Postgres and this version, 16.1, because it's the one that we are running on production, so we should always use the same. So what we do here, it's basically saying, yeah, start a Postgres container for this specific version. So if I run the same test again, and I put it something good, I think it's going to pass. It's taking a few seconds, and we will see how. So the test is now green. So let me show you here what's going on. I have watch here. So this is Docker PS running. Let's run it again. So you can see here, you are going to see two containers, Postgres and Ryuk. So every time you start a test container or a test, Ryuk will be started. Ryuk is basically the manager, the one that manages everything. So the library will start Ryuk, and it will tell Ryuk, you need to start these containers, and you need to make sure that you stop all the containers after the test pass or fail, after you finished, and then Ryuk will stop itself, right? So that's why we cannot see any more containers running. So basically, we are good. We fix this. We can move to the next test. The problem with this approach is that it only works for databases, right? So if we don't have a database, we have Kafka, we cannot use this kind of trick to build a URL this way. So if we want to follow another approach to not use this kind of trick, what we need to do basically is saying static Postgres container, new Postgres container, Docker image, and here we need to pass which Docker image we want to use. And again, it's the same as before. We want to use the same image that we are running on production. So here we are defining a Postgres container that uses this image, and the next thing we need to do is we need to tell Spring where is my Docker container, right? Because with this trick, the library would do that for you, but without that, you need to tell Spring these 3 properties to be able to connect to the instance. So to do that, there is this dynamic properties. So you know that the Spring has different property sources from where it can read configuration, environment variables, configuration files, a lot of things. And this one is dynamic because you can run them on the fly, right? Not just before running the test, but, sorry, it will execute it just before running the test, but with the application kind of in the middle of the starting. So you can define different things. Set up containers. And here we have a dynamic property registry. So basically what we need to tell here, we need to add the configurations. And it's the same as before. We need to put the password. We need to put, I hate this keyboard, the URL. And we need to put here the username. And how do we know that? Because basically we ask the container, okay, please give me the password, give me the username, and give me the JDBC URL, right? So now the only thing we need to do basically is start in the container. Start tables dot postgres.join. So this is going to start a list of containers in parallel. Now we only have one, but when we add the Kafka container afterwards, it will start both of them in parallel. So this is going to basically start the container, and after the container has been started, it will ask the container, give me this information, it will configure this property source for Spring, and then the application will continue to start, and it will have this information configured. So we can run the test again, and yeah, it failed because it needs to be static. Actually, static void. So you can see it takes a couple of seconds because Postgres, it started in around 1 second, 1.5 seconds, but the test passed. So basically, all these bunch of code is the equivalent to this line here. So if you are only, if you only have a database, I suggest to go with this approach. But if you have more containers, it's easy to do this because everything will be like the same, right? So now the first test passed. I have here another one, which is I defined one dependency which on my build.gradle, the actuator. So I want to make sure that the application is healthy. And here, what I have here, it's this dependency is called REST Assured, and it's a really nice library to test RESTful APIs in a simple and nice way, because you can see, sorry, before that, this code here I had, so before each test, I'm defining basically, this is from this REST Assured library, so I'm setting the port in which, so this local server port is the port in which the Spring application started. It's a random port, and then I set the header saying, yeah, we talk with JSON, and that's it. So you can write this test in a very readable way, right? When I send a GET request to actuator health, then I expect the status code will be HTTP OK, and please, if something fails, log the error with a lot of details to know what's going on there. So we can run it again, and it should pass because the connection to the database worked and the application started properly, right? So it's green. And now, what we are going to do is actually, we are going to test this use case. We are going to send a message here. It's going to return the UID, and we are going to basically send GET request to the message service saying, is the message signed, is the message signed, is the message signed, until it is. So, same as before, when I send in the body this plain message as opposed to this endpoint, in the response, then I expect the status code to be accepted, because that's what I was returning here from my controller, accepted. Remember this header? So what I do here, then in the response, I extract the header location. So you can see it's basically plain English. You can read it very simple. I extract the location, and here basically I'm removing this. I could have used a regexp to extract the UID, but it's simple this way. I log it so we can see on the logs. And here, these are two ways to do the same thing. So you don't need to do both. I just showing you here 2 ways to do that. You can choose one or the other. This is grab in this await until asserted. This comes from a utility, this library to test asynchronous processes or executions. Because if we don't do that, remember that I put a sleep from 1.5 to 3 seconds. So if we don't kind of wait and just run the check after sending the post request, the test is going to fail because the message is not going to be signed. So this is going to be executed until there is a timeout. I think by default it's like 10 or 15 seconds, or until everything passed, the assertions are true. So in this first approach, what I do is I send the GET request to messages/message ID. This is the ID I extracted from the header. And then I extract from the JSON body the signature. I save it here, and I basically assert that the signature is not null, meaning that the message was already signed. This is one approach. The other one is sending the same request, and then allowing the library to extract all the information. So basically say, from the JSON body, extract the signature, make sure it's not null, and also extract the sign act, and make sure it's not null. So remember this. These are null when you send the post request, and after a couple of seconds, they will have some value there, right? So before running the test, we need to add the Kafka dependency, because if not, the test is going to fail. So what we are going to do here is pretty much the same. Static, let me do this Kafka container. Oops. We create the new Kafka container, docker image.parse, and again, which Kafka container we are going to use? The same one that we are using for our Docker Compose for local environment, and this version should be the same one that we use on production. We need to start here Kafka container, and we also need to provide here registry at Spring Kafka Bootstrap service. This is the configuration property I have here, right? So we need to provide that information, and again, the same as before, from where do we get that information? Just ask the container, get bootstrap servers, right? Oh. So now we are starting also a Kafka container, and hopefully, if I didn't miss anything, this is going to run, it's going to pass. So remember this, now we have also Postgres, we have now Kafka, we have Ryuk. Kafka takes around 5 seconds to start, that's why it was waiting a little bit, but the test passes. And as you can see here, we have here Postgres and Kafka starting parallel, because I started them in parallel, then my application starts. You can also see here that the flyway migration is executed, so it creates the schema on the database, and then start the test, and you can see here requesting to sign a message. This is the ID, so this line is from the sign message test. So this line comes from this one, right? This is a UID, and then a couple of seconds later, the test passed. So let me show you how this works under the hood. So if we go to my controller, this is the endpoint we are kind of polling all the time. So we can say here, sort M, sort P. So we can see the output on other requests. So what is going to happen is that we send the post request, the process will wait a couple of seconds, and in between we are going to see a lot of requests, a lot of, you can see here, because the block that we have, this until asserted true, it's sending get request to basically get the information, and once the message is signed, we have the last one. We have two, because remember that here we are running this, right? These two approaches. So we can, for example, go with the first one, and now, I hate it. And now we are only going to see, after the message is signed, we are only going to see one more get request, and then the test will automatically pass. Right? Now, when you see this blank screen in LEA, is because the container is running, is starting. And as you see here, after the message has been signed, we only have now one get. You can also configure the library to say here, I just want to send one request every some seconds, to basically avoid polling the endpoint all the time, right? It has a lot of configuration options. And here I have the last test, which I'm sending 5 post requests, and I call the other endpoint, the one that returns the list, to get all the messages. So what I do here is I extract the body, and on the JSON path, I just extract a list, and the library automatically do the marshalling, the JSON and marshalling to my Java object. And I'm going to assert that all messages have basically signature. So running this, what we will see on the logs is the 5 requests, then all the 5 messages are going to be signed, and after the 5th one, the test will pass. So you can see here, requesting to sign a message sign, hello Thurn, you can see 1, 2, 3, 4, and after the 5th one is signed, the test gets passed. Right, so everything works. So yeah, so this is nice, and you saw here that it started the container for you, it stopped, and you didn't worry about that. The problem for some of you that has Apple M1, 2, whatever, is that at least at the very beginning there wasn't ARM images for your dependencies, right? So I'm running Linux, I don't have those problems, but I know that a lot of people had problems with that in the past. So what you can use, instead of having your Docker running locally in case there isn't an ARM image for your dependency, what you can use is using basically Testcontainers Cloud. So it's a test container as a service. You can sign up for free. You have some minutes or some runs, and you will see here a nice dashboard. You can install an agent on your laptop for every operating system. You can also use this on CI, and basically, so I have it installed here, and you can select here if you want to use, or you want to run this locally with, in this case, this is my local Docker daemon running on my laptop, or I want to use Testcontainers Cloud. So what we are going to do now, I'm only started the agent, and we are going to run, for example, this one. And let me show you, I'm going to put this here, so you can see that no Docker container is going to be started locally. It's going, you can see here the play button there. So it's running on Testcontainers Cloud. And it's going to take a few seconds the first time, because what this does under the hood is my test containers, my test is connected to that through the agent to Testcontainers Cloud. I got a runner assigned from their Google Cloud pool, and the first time I got the runner assigned, it needs to pull all the images, right? The same as you do if in your laptop. The first time you need to do Docker pull, and it will download all the images. So the first time, you saw the test pass, you saw that nothing was shown here. So you can see here 2 things. Server, Testcontainers Cloud via Testcontainers Desktop, and remember, I showed you before here it was Linux Mint, it was my laptop. This is not my laptop, this is the Ubuntu runner I had running on the cloud. It has 8 GB of RAM, and as you can see, it's pulling the Postgres image is pulling the Kafka image, so it takes time, especially Kafka is kind of huge, and then everything is run as before. So if I run the same test again, it's going to take way less time, because the runner has already the image cache, so it only needs to wait to start Postgres, to start Kafka, wipe everything, and basically wait until the test pass. You can see here that there is no Docker pool, just creating the containers. So Postgres, 1.2 seconds to start, and Kafka, where is it? It takes more time. I don't know where is it. Yeah, 5 seconds to start Kafka, right? So if you run this, you need to pay this price. Sometimes you don't want to start Kafka, especially if your dependency takes too much time. You don't want to do that all the time. You can run the container and then run all your tests. Let's switch to my local one. And the last thing I want to show you is that this is nice, but this is kind of verbose. So what you can do, whoops. So one of the things that the Spring team did from Spring Boot 3.1 is basically making the whole developer experience better. So what you can do now is you can annotate it with Testcontainers, and you can say here, this is a container. So these two annotations are for Testcontainers, but there is a new one called Service Connection from Spring. And this connection or this annotation tells Spring Boot that you are running a container and basically it needs to figure out how to wire everything for you. You don't need to worry about that. So I commented all this out, and let's run this one again. And you can see it starts the containers again, but I don't have any configuration for that, because Spring Boot knows how to deal with the most used containers, so all the databases, Kafka, Rabbit, a lot of integrations, right? Redis, and it wires everything, and it can auto-configure itself once. When it sees this annotation, it knows how to create this under the hood, so we don't need to. And the last thing I'm going to show you, and with that I'm going to finish, is do you remember that I have here this dependency, Spring Boot Docker Compose, right? And it's on implementation scope. So this is because there is another integration that was also introduced in Spring Boot 3.1, which is this one, integration with Docker Compose. I had disabled, but I can define it as true, and the lifecycle management is, you have these three. I put start only, and what I'm going to do, I'm going to basically comment this out, and I'm going to comment this out. So no configuration for my database, no configuration for my Kafka broker, just my Docker Compose, and I'm going to start again. So remember, there is no container running. I'm going to start again my application, and as you can see, containers are here, and if we take a look here at the output, we see here using Docker Compose file and creating containers. So basically, Spring Boot knows how to do everything for you. It reads your Docker Compose file, and using this kind of the same thing under the hood that the service connection annotation uses, it can create the containers for you. It can wire all the configuration, but this time for development environment, not for testing. So you have both approaches if you want. The application is up and running, and I can probably send here the same post request and the same get, not this one, but this one, right? And everything works because I have my 3 containers running. But the nice thing is that you don't need to worry about that. You can get rid of a lot of configuration. So basically, on your README, you can just make sure that you have run Docker install and execute Docker run, and that's it. And as I had this configured with start only, it will. I just stop the application, so it will store the containers, but don't stop them. If you put here start and stop, it will stop the containers every time you stop your application. That maybe for local development, this is not what you want, right? So I think that's it. Thank you very much. If you have some questions, if you have like 30 seconds, please go to that QR code or that URL, bit.ly/sbstc. It's an anonymous form to give me some feedback about the talk. It will only take you 30 seconds, only for questions, and it's anonymous. If you like the talk, let me know. If you think the talk was crap, let me know. I don't care. It's anonymous. You can say anything you want. I won't be offended. Just give me some feedback. I'm going to push the code to GitHub. I'm going to push the slides, so you will have all this code to play with it. I have here some test containers stickers that you can grab it now. And I will be here for the rest of the conference, so if you want to talk about anything, just reach out and I will be happy to talk to you. And if you have any questions, I think we have a few minutes. So yeah, thank you.